Hi everyone, so today we're going to be extending what you did in class yesterday with factoring the sum and difference of cubes and quadratic form. So let's just review the factor patterns for the sum and difference of cubes. So if you have x cubed plus y cubed, that's the sum of two cubes. Why are they cubes? Because they're raised to the 3 power. The factor pattern, which I'm going to show you where it comes from when I get back to school, but for now you have to memorize it. X plus y and then x squared, change the sign to negative, to the opposite, multiply the x and the y, and then square the last. And the same is true for x cubed minus y cubed. So you get x minus y, x squared, change sign xy plus y squared. Now, it's really important to know we're going to be solving these now. So you've just been factoring them. Now we're going to have them set equal to 0, and we're going to solve. So we're going to set each factor equal to 0. But it's really important to know that this trinomial result you get is actually not factorable. You have to use the quadratic formula to solve it. Okay, you have to. All right, so let's look at an example. It says find the real or imaginary solutions by factoring. So first we look at it, and I'm actually going to, let me change this. This should say x cubed. Okay, so I look at it. I see two terms. I check to see if there's a GCF, go through my process. And then if it's two terms, I look to see if it's dots. It is not dots. So then I check for the sum or difference of cubes. And I see that 8x cubed is a cubed and 27 is a cubed. So step one would be rewrite it as their cubes. So I rewrite this as 2x cubed plus 3 cubed. Now I do that because then it helps me follow the pattern very clearly. Because now I'm going to factor it. So I get 2x plus 3. There's that x and y. Now I square the x term, so it becomes 4x squared. I change the sign. I multiply the 3 and the 2, so minus 6x, and then I square the 3, or the y, so plus 9, equals 0. Okay, so now we've factored it using the sum and difference of cubes pattern. Now we set each factor equal to 0 and solve. Really nice, this first factor is just a linear factor, so we subtract 3. And we get 2x equals negative 3. We divide by 2. And so I get this nice solution or root or x-intercept for this cubic function of negative 3 halves. Now this other one, like I said, this is the trinomial piece. It's not factorable. Even though a lot of kids want to think it's a perfect square trinomial, it's not. Because if it were a perfect square trinomial, that would have to be a 12. All right, so I'm going to use the quadratic formula. So I'm going to identify my A of 4, my B of negative 6, and my C of 9. Okay, so then I plug it right into the quadratic formula. X equals negative 6, okay, plus or minus the square root of. All right, negative 6 squared is 36 minus 4 times 9. Okay, all over 2 times 4, which gives me 8. All right, I'll give you a second to make sure you see what I did there. Now, I'm going to simplify. So I've got a negative, which becomes positive 6, plus or minus the square root of 36. Now, I notice there's only one minus here, so it's going to stay negative. And then 16 times 9 is 144. So you might already be seeing that I'm going to have a negative under the root, which means it's going to be an imaginary root. Okay, so now I simplify some more and I get 6 plus or minus the square root of, and this works out to be negative 108 all over 8. All right, now I'm going to actually simplify that, but I'm going to come off to the side to do that, okay? So negative 108. So the first thing I'm going to do is I'm going to pull out that negative and make it I. And then I know that 108, if I cut 108 in half, it's about 54. So that tells me I can start at square root of 49 to see if that goes into it. Square root of 49 does not go evenly into 108, so then I go to 36. And lo and behold, square root of 36 is a factor of 108. It's the square root of 36 times the square root of 3. So that gives me a reduced expression of 6I root 3. All right, so now I'm going to go back to my quadratic formula, and I'm going to put that in, 6I root 3 over 8. And then I'm going to simplify that to 6 over 8 plus or minus 6I over 8 root 3. And then I'm going to simplify the 6/8 to 3/4. So 3/4 plus or minus 3I over 4 root 3. Now, so we have only one real x-intercept at -3/2. So these, although they are roots, they're imaginary roots. And remember, we can't graph those imaginary roots on the coordinate plane. They have their own imaginary plane. But we still need to consider them as roots. And we'll be talking about what happens to the graph when you have those imaginary roots at another time. All right, let's look at one in quadratic form. Love quadratic form, okay? So now, don't be scared with quadratic form. You were working on this yesterday, and it's quadratic form if it's a trinomial and it appears to be quadratic, meaning it has a power of, that's an even power. So I can see that. I can factor this, but instead of using x and x, I'm going to use x squared and x squared. Why? Because x squared times x squared equals x to the 4th. All right, so then I'm looking for the factors of positive 16 that add to a -8, which would be -4 and -4. Okay, now you may notice those are exactly the same, okay? So we really only have to do this once. We're going to do x squared minus 4 equals 0. I'm going to use the square root method here because there's no linear term. So x squared equals 4. And then I take the square root of both sides and I get x equals plus or minus 2. Okay, and so those are the real solutions to this quadratic form equation. And you're going to be practicing it now with worksheet 5.3, okay? And I appreciate you guys being really good with the sub and doing your best to focus on this material. And hopefully I'll be back soon. Thanks so much, guys. Have a great night.